Hi friends, today we are going to discuss on the topic transmission gate. In the previous video on Pau's transistor, we saw that in Pau's transistor, end-to-end swing is not possible. We will deal with that issue in transmission gate. In transmission gate, we can see that it is a combination of PMOS and NMOS. So we take in the advantages of PMOS and NMOS. That is, PMOS can transmit strong ones, NMOS can transmit strong zeros. So together, end-to-end swing is possible here. So when we are transmitting logic 1, which takes a path through PMOS, and when we are transmitting logic 0, which takes path through NMOS. This blue color symbol here is the symbol for transmission gate that we normally use for circuits. Now let's see the regions of operation in the transmission gate. So here you can see a graph here. So the x-axis of the graph is Vout, and we mark the regions based on the basis of Vout. So first region is between 0 to modulus of VTP. So we take VTP as a string condition here. So first we will analyze NMOS. So to check it, first we have to see what VGS is. We have VGS equal to VDD minus modulus of VTP. So that is definitely greater than VTN. So NMOS is on. Now we have to check whether it is working in saturation or active region. So for that we have to compare between VDS and VGS minus VTN. So here VDS is VDD minus modulus of VTP, and VGS is as shown above, it is VDD minus modulus of VTP minus VTN. So this term is obviously greater than the right side term. So here VDS is greater than VGS minus VTN. So that means NMOS is in saturation. If VDS is greater than VGS minus VTN, that's the condition for saturation. So NMOS is in saturation. Now let us go and check the condition for PMOS. Here it is modulus of VTP. Okay, here first we have to check whether it is on or off. So we check VSG. Here VSG is equal to VDD, and that is definitely greater than modulus of VTP. So PMOS is on. Now we will check whether it is in saturation or linear. For that we have to compare between VSD and VSG minus modulus of VTP. Here what is VSD? It is VDD minus modulus of VTP. And what is VSG? VSG is VDD. So, and here minus of modulus of VTP. So these terms are equal. So we have a condition that if VSD is greater than or equal to VSG minus modulus of VTP, it should be in saturation. So PMOS is in saturation. So now let us analyze the second region. So in second region, the output is in between modulus of VTP and VDD minus VTN. So we can take the extreme part, that is VDD minus VTN. So as earlier, we'll analyze NMOS first. So what is VGS? VGS is equal to VDD minus this part, VDD minus VTN, that is equal to VTN. So VGS is now equal to VTN, so it is on. So now let us check whether it is in saturation or linear. For that, first we compare VDS, then we have VGS minus VTN. So what is VDS here? VDS is VDD minus VTN. So that is minus VTN, that is equal to VTN. And what is VGS minus VTN? VGS is VTN and minus VTN is 0. So this will be VTN. So this is anyway greater than 0. So NMOS is in saturation mode. Now we will check PMOS. So in PMOS, first we will check whether it is on or off. So what is VSG? VSG is equal to VDD. So PMOS is on. And now we check in which region it is operating in. So we check between, compare VSD and VSG minus modulus of VTP. Here VSD is VDD minus of VTN, that is VTN, and VSG minus modulus of VTP is VDD minus modulus of VTP. So here VSD is less than VSD minus modulus of VTP. This term is greater than VTN. So that means PMOS is in linear region. Now let us take third region. In third region, it is in between VDD minus VTN and VDD. So we will take the extreme condition, that is we will take V out as VDD. So first we analyze NMOS. What is VGS here? Here VGS is equal to VDD minus VDD, that is 0. So NMOS is cut off, that is NMOS is off. So NMOS is off or cut off. So now let us analyze PMOS. For that, we first check what is VSG. So here VSG is equal to VDD, so PMOS is anyway on. Now we'll check whether it is in saturation or linear. For that, we compare between VSD and VSG minus modulus of VTP. So here what is VSD? VSD is VDD minus VTP, that is 0. And what is VSG minus modulus of VTP? That will be this VSD. So VDD minus modulus of VTP. So this term is definitely greater. So VSD is less than VSG minus modulus of VTP. So PMOS is in linear region. Now we will try to implement some circuits using transmission gate logic. So here we are going to implement XOR, and on the right side we can see a circuit which is similar to the one that we saw in the pass transistor logic. So here the bubbled part shows PMOS and non-bubbled part shows the NMOS. So we will be concentrating on what input we are giving to the NMOS to analyze the circuit. So when B is 1, we want to check what we are going to pass. So when B is equal to 1 and when A equal to 0, we get output as 1, and when b is equal to 1 and when a equal to 1 we get output as 0. That means we are passing a bar. So and when we have b is equal to 0, that means when b bar is connected to NMOS in this line, that is when b is equal to 0 we have, and when a equal to 0 we have output as 0. When b is equal to 0 and a equal to 1 we have output as 1. So that means we are passing a. So now let's see another circuit. Here we try to implement mux. So for that we have selector line S. So when S equal to 0 we need an output A. That means we'll pass A. When S equal to 1 we will pass B. So when S equal to 0, this is the X bar line, so we pass A, and when S equal to 1 we pass P. So today we saw the basics of transmission gate and its regions of operation and how to implement circuits using the transmission gate.